Chemiosmosis. ATP synthase, harnessing the power of protons to synthesize ATP.
This is a mitochondria. A mitochondria has two separate membranes. The outer and the inner. The inner has a matrix, while the outer has an intermediate space.
This is the overview of the electron transport chain. This is the outer part of the membrane, and this is the inner part. In the inner part, it consists of 4 complexities.
The electron transport chain establishes the proton gradient. The proton moves in the intermembrane with the high concentration that the mitochondrial matrix. It moves from the intermembrane to C1 complex, C3 complex, and C4 complex. But there is another entrance where protons can move in the ATP synthase.
Okay, so we know that this is the inner membrane, and most of the protons are, there's a high concentration of protons here and a lower concentration, so the tendency is for the protons to go down. So the protons go to the ATP synthase. Inside the ATP synthase, they diffuse. And as they diffuse, they let out an energy because it is an exergonic process. The amount of entropy in the system is increasing. So from that energy, the energy is the one that supplies us energy for the fusion of ADP and phosphate. So once they fuse, this is when ATP is created.
Let's have a little recap. We know that in mitochondria, this is the figure of mitochondria. Inside the mitochondria, there are 2 different membranes, the intermediate space and the matrix. As we see here, this is the lipid bilayers, and this is the complexities. This is where the proton highly concentrated, just as stated in here. The protons are in here but not here. So what is the tendency if something is has much more and the other one has less? Based on the osmosis, we know that osmosis have different concentration. If the concentration is high, they will balance it with other, let's say, place, or it will go to another place based on osmosis. So we know that osmosis is that process. It becomes chemiosmosis when we produces chemicals.